Okay, so this is my fill-in lecture. I think I was missing the top of page 4. Okay, constitutional isomers are sometimes referred to as structural isomers. What they are is they have the same molecular formula. That does not stand for, that's molecular formula, not mother, yeah. So same molecular formula, different structure, and different name. All right, so if you are asked to determine isomers, I don't expect you to know how many isomers there are. What I will ask you is, for instance, C4H10, draw 2 isomers for this one. C5H12, draw 3 isomers for this one. C6H14, draw 5 isomers for this one. I never would expect you to come up with like, oh, it just has 2. So when you're asked to draw isomers, which will most likely come up, you need to pay attention to a couple of things. The molecular formula. C4H10, that adheres to this formula we'll talk about a little later on in the note packet, but it's CnH2n plus 2. So what this tells me, these are straight chain alkanes. Okay, let's check this one. C5H12. So 2 times 5 would be 10, plus 2 would be 12. So yes, this adheres to this as well. So these are both straight chain alkanes. Now what happens when I ask students to draw 2 isomers? Students will draw the same thing over and over again. They'll just draw butane but around the corner. They'll draw, it's the same thing. So you really need a systematic approach to this. And it has been my finding that students freak out when they hear isomers. I hate isomers. I hate organic chemistry. I just want to quit. Don't quit. It's going to be on the exam. I guarantee it will be on the exam. So you're just going to have to, figure out how to do it. My advice is to start with the longest chain first. So for instance, this one would be a chain of 4. And for C5H12, it's going to be a chain of 5. Okay, so the chain of 4 would be C. Okay, and then you fill in your hydrogen, CH3, CH2, CH2, CH3. 2, 4, plus 3, plus 3, that gives you 10. So hey, look, it's a straight chain alkane. This is my first isomer, and I'm going to name it. It's called butane. Another tip that I have for students with isomers is to name your isomers even if it doesn't ask for it. The reason I say name it is because you will pick out duplicate molecules easier that way, as long as you're naming them correctly. All right, so C5, straight chain of C5 would just be 5 carbons in a row, CH3, CH2, 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 CH3. This is pentane. Okay. So for butane, I need 2 isomers. I've got 1 isomer and it adheres to this formula, so I don't think I'm going to be able to rearrange it any other way. It's still going to be called butane if I keep a chain of 4. So I'm going to move down to a chain of 3. Well, if I move down to a chain of 3, in order to get C4, I have to park a carbon somewhere. So I have to park a methyl group. If I park it at the ends, I'm just going to get butane again. However, if I park it in the center carbon, that is not butane. So prove this to yourself. Try to find the longest continuous chain of carbons. Well, here's the longest continuous chain of carbons, or you could do it this way too. I have a methyl group coming off my second carbon. So this is 2 methyl propane. CH3, CH, CH3, CH3, so 3 times 3 is 9, plus 1 10. So 2-methylpropane. So I came up with my 2 isomers for C4H10. Easy, right? Well, the more carbons you have, the more isomers are possible. So for C5H12, I'm going to have to work a little bit harder. I have 3 isomers. So next I'm going to go down to a chain of 4. And I'm going to have an extra carbon to park. And I can park the carbon here or here. Now, this chain of 4 is symmetrical. You see that mirror right there? So if I park my methyl here or here, it doesn't matter. It's going to be the same. It's going to be 2-methylbutane. So CH3, CH3, CH, CH2, CH3. See, 3, 9, 11, 12. Yeah. So this is 2-methylbutane. Okay? Now, if I move this methyl group over here, it's still going to be 2-methylbutane. I'm going to number the other way. So instead of from left to right, I'm going to number right to left. All right, so I'm not going to be able to come up with any other isomers. If I put this methyl group on the ends, I'll just generate pentane. So I need to go down to a chain of 3. So, chain of 3. I have to be careful with this chain of 3 because I get students who are like, oh, well, I have 2 carbons to park. I am going to park these carbons right here. I'll make an ethyl group, and that will be, that's my main, my parent chain. So that's going to be 2-ethylpropane. Wrong. This actually is the same thing as above. You see how easy it is to draw the same molecule a different way but not realize it. So that is not an isomer. Back to the drawing board. I got to get 3 carbons. And I got to park 2 carbons off this chain of 3. I cannot have them connected as an ethyl group. I can't put them here. I can't put them here. So I'm going to park them separately as methyls. Oh, my hydrogens. See, you've got it here. There's 3 times 4 gives you 12. Bingo. We found our isomer. So it's 2,2 dimethylpropane. Well, you can read that. So for isomers, I always encourage students to take a logical approach. Otherwise, you're going to get into this weird system here. So start with the longest chain first and then move down. And always look for symmetry. Always look for the same ways to name it, but you just number from a different way. That's a way to avoid duplicates. And that completes this fill-in lecture.